Okay, let's put you back on Earth now. So we are now on Earth. Gravity on Earth is 10 meters per second squared. We're going to fire a cannonball 80 meters per second at an angle of 59 degrees. Or will we be able to? So we're going to fire a cannonball. Will we be able to blow up this building, which is 90 meters high, and it's 150 meters away? So yeah, press pause and have a go. Try to locate the location of the maximum height. So well, once you've got the location at the maximum height, you get a rough idea of what's going on. So the maximum could be over here. So when you fire the cannonball, it could do something like that, or it could the maximum height could be over there. Well, find the location of the maximum height, and then so just so that you can have a rough idea of what's going on. And then once you've got the location of the maximum height, work out if you're able to blow up this building if you were to fire it at this speed and at this angle. Okay, so press pause and have a go. Okay, so in order to do this, break this up into its vertical and horizontal. Okay, and then jump to your velocity time graph. Remember, you're trying to find out the location of the maximum height, but in order to do that, we need to find out the time it takes to get to the maximum height. So at the moment, we are finding out the time it takes to get to the maximum height. So at the maximum height, the velocity will be 0. So put 0 into this v. Work backwards to find out t. Okay, so here you put it 0 into the v, and then you're working backwards to find out t. So t, this is the time it takes to get to the maximum height. Okay, and then now that you know the time it takes to get to the maximum height, your velocity time graph now looks like this. We now have more information. You see, this is the point at which the cannonball will reach its maximum height. So that this is the time it takes to get to the maximum height. So the area underneath the time graph, the graph here, represents the distance traveled. The area underneath this graph here represents the actual maximum height in meters. So work out the area here. So it would be the height times the width, and then divided by 2. So this is the height times the width, and then we divide it by 2. So so it becomes this, and then blah 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 blah. So the maximum height is given by this. Okay. So now we've got some idea of what's going on here. So we know that we know that the maximum height is this, the maximum height. So let's just guess. Let's just guess the maximum height is here. Okay. Now the height of the building is 90. Maximum height is 200, and let's say it's 200. So this is what, let's say 100, 200. So the maximum height is somewhere here, roughly, maybe slightly higher. So we can make some guess, but the thing is, we know the maximum height is at this level. But the thing is, it could be over here, or it could be over here. We don't actually know. We were just guessing it's directly above the building. But it could be before the building, or it could be after the building. We need to find out the horizontal distance of the maximum height, because it could be this. It could be this scenario here, or it could be this scenario here, or it could be this scenario here. We just know that the maximum height is roughly around here. It's at this level, but we don't know if it's before the building or if it's after the building. Now, in order to find that out, we know that the time it takes to get to the maximum height. Let's just guess it's here. We know it takes 6.86 seconds to get to the maximum height. So now imagine. Hang on, let me just move this across. Hang on. So now imagine you and your dad sitting in a car here, driving at this horizontal speed here. Now, if you were to drive for 6.86 seconds, how far would you get? So now, well, up here, we we know the maximum height, but we don't know how far across it will be. It could be over here, or it could be over here. So you have to imagine you and your dad sitting in a car here, driving along at this speed for for 6.8 seconds. Okay, so how far would you and your dad sitting in the car get? If you get to this here, if the car gets to this point here, then you know the maximum height is here. Now, if the car is able to get all the way here, then you know that the maximum height is after the building. Okay, so let's try and work this out. So now imagine you and your dad sitting in a car here, um, sitting in the car doing this speed here for 6.86 seconds. So the distance, the horizontal distance covered will be 282.65. This figure here. Okay, so what that means is that, hang on, so you know the maximum height is this, and you know that the horizontal distance of the maximum height is 200 and something. But in our original question, the building is only 150 meters away from the cannon. So let's just say from here to here is 300. Okay, round this up to 300. So 150 is probably around here. So our building is around here. But the thing is, we know that the actual height here is this. So the building is 90 meters high. Well, let's just say this is 200, 100 is here, 90 somewhere here. So our building is 90. So we're just going to guess our building is roughly here. So the maximum height is here. This distance away, our building is here. So what's really happening now is that we are now able to build up a rough picture of what's going on here. It's doing that. Now the question is, how high above the building is this? When the horizontal distance reaches the building, what will be the height of this cannonball above the building? Okay, so in order to do that, let's just look at this here. The building is 150 meters away. Okay, so what you have to do is get this distance here. Hang on, get this distance here divided by the speed of the car, and then that will give you the time it takes to get to the building. Okay, that gives you the time. Remember the time. So time to get to building equals the distance of the building divided by the speed of the car. That gives you this. So what that means is that the cannonball takes 3.64 seconds to get to the building. Okay, so now your velocity time graph looks like this. It takes 6 point blah 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 seconds to get to the maximum height. The building is here. Remember, going along here is time. Okay, so we are now talking about time. This time here is 3.64 seconds to get to the building. So how high above the ground will the cannonball be at the building? So you have to work out the area here. This represents the vertical distance above the build. Well, the vertical distance at the building. Okay, so we need to work out the area of this thing here. Well, this area here is just the trapezium here. So we can use the trapezium rule in order to work out the area. Well, this thing here is the initial vertical velocity will be this. Okay, so this is our trapezium here. This trapezium here, I'm going to enlarge it. So now it becomes this. Okay, this height here is given by this, and this height here is given by, well, what you have to do here, because you want to know the height of this thing here. If you want to know the height of this thing here, you have to put this t into this equation here. Remember, this equation here represents the diagonal line. Well, if you put this into the t here, it will take you to this height here, because this is an equation for that diagonal line. Okay, so put the t in there, and then it will tell you that this height here is given by this, and this height here is given by this. Okay, and remember the cross here is the time it takes to get to the building. this number here. So all you have to do, get the height, which is this, plus this height here, which is this, add the two together, divided by 2, that will give you the average of the two heights. Okay, that will give you the average of the two heights. So you just need to times it by this. Okay, so the area is this. So what that means is that this is the height of the cannonball when it gets to the building. Okay, so this number here is this here. This number here. So the height of the cannonball when it gets to the building is right here, roughly here. So you just have to guess here. Well, let's just say the height of the building is 90, maybe double it. So guess it around here. The maximum height is over here when it's 280 blah 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 meters away. Well, the height above the building is this. So our cannonball clearly will miss the building. Okay. You don't actually need to work out the maximum height in order to answer this question. But when you come to do this, actually work out the location of the maximum height, just so that you get an idea of what's going on. And then jump to the building here, and then actually work out the height above the building. But this is quite important. So work it out, just so that you get a rough idea of what's going on. Okay. Now I'm going to go back to the beginning and then scroll through the answer so that you can see for yourself. Okay. And then you can pause it whenever you want. So I'm scrolling through. Hang on. Yeah. Okay, scrolling through. So yeah, just I've rubbed off all my well, anyway, this is what you have to just follow it through. Okay, that's it. Okay.